Section 8.2, Series and Arithmetic Series. Series and Arithmetic Series. So what we have in the previous section, we talked about sequences and arithmetic sequences. Here we talk about series. What is a series? Remember we had, let's say, 5, 8, 11, 14, 17, etc. This is a sequence. If we happen to add these numbers up, 5 plus 8 plus 11 plus 14 plus 17 plus this is called a series. So the series is basically the sum of all the terms of the sequence. To help us with series, because we write a lot of terms adding together, we can use the sigma notation. This is called sigma. It's a Greek letter sigma. It's used for summation. Some people call it summation notation. So for example, to see how this sigma is being applied, so let's say we are asked to find the sum of I squared from I equals 1 to 4. From I equals 1 to 4. So what you do, you substitute 1 in squared, 2 in, 3 in, and 4 in. So we get 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And all we have to do is just add them up, which gives us 30. So that's a sigma notation. They can give us in a different way to ask us to find another example on sigma. 3n minus 1, n equals 1 to 4. How do you find that out? You substitute n equals 1, so 3 times 1 minus 1. Substitute n2, 3 times 2 minus 1. Substitute n3, 3 times 3 minus 1. Substitute 4, 3 times 4 minus 1. And what does that give us? 3 minus 1, 6 minus 1, 9 minus 1, 12 minus 1. So that gives us a 2 plus 5 plus 8 plus 11. And if we add all of that up, that gives us 26. So why do we have to know this sigma notation? Because it makes things easier for us. It makes things easier. Instead of writing all these summation thing, we can just write it with one expression. Let's look at another example. What about the sum of negative 1 to the I times 3i? I goes from 2 to 5. So let's see what we do. We substitute I2 first, negative 1, 2, 3 times 2. That's the first one. When I substitute n equals, so this means from I equals 2. That's where it starts. Then you take I equals 3. So negative 1 to the third, 3 times 3. Take I equals 4. Negative 1 to the fourth, 3 times 4. Take I equals 5. Negative 1 to the fifth, 3 times 5. Negative 1 squared is 1. So 3 times 2, 6 times 1, 6. This is 9 times negative minus 9. 12 times this is plus 12, minus 15. This gives us, this is negative 3, and this is another negative 3. So that gives us a sum of negative 6. Notice the sum could be positive, could be negative, could be 0, could be decimals, fractions, it doesn't matter. It doesn't have to be always positive. Recall from last section we told you that, let me write it as a note, negative 1 to any even power is always positive 1, and negative 1 to an odd power is always negative 1. Now, can we go backwards? Like if they give us the sum, can we write it using sigma notation? So write each series using summation notation, the sigma notation. Let's look at the first example. So if we try, let's look at this 3 plus 6 plus 9 plus 12. Let's say something like this. The sigma notation or summation notation is going to look like this, something an, and n goes from some numbers to some other number. So n goes from somewhere to some other number. Well, first we need to find what an is. An is the general term. Notice what is it? What's the pattern here in these terms? Well, every time this looks like 3 times n, because It's if you take n equals 1, you get the first one. Take n equals 2, you get 6. N equals 2, you get 9. N equals 4, you get 12. So we go all the way up to 12. So it's kind of for now like guess and check. Another example, say negative 1/2 plus 1/4 minus 1/8 plus 1 over 16 plus dot dot dot. So I put 3 dots at the end. So sigma, what's the pattern here? In the top I see 1s first, and the denominator is a multiple of 2, like 2, 4, 8, so it's 2n. And n should start at 1, but there is a negative sign, then positive, then negative, then positive. This should be negative. So it's an alternating sign, alternating. Every time there's an alternating in the sign, there has to be a term of negative 1 to the n or negative 1 to the n plus 1. We have to test, see which one works. So if you put here negative 1 to the n and substitute n equals 1 in here, as we did in the previous section. So you're going to get 1 times negative 1 to the 1, 2 times 1. That's a negative 1 over 2. That's the first term. So that works. If it doesn't work, if you got plus 1/2, then you use n plus 1. So where does this go to? If you substitute n equals 2, you get the next one. N equals 2, you get the next one. 4, you get the fourth term. But then it says dot dot dot. That means it goes forever. And the way to represent this, we put infinity. Infinity means it goes forever. This is called an infinite series. Infinite series. It means it goes forever. What other things good to learn about this? Note something. When we wrote something like n equals 1 to, let's say, k or something, any number k. So this is called the index of summation. Index of summation. And so some people call it lower bound, and the k is the upper bound. But those are the indices of summation. Sometimes we can change the index, so we can make the index to start at a different number if we like, but to keep everything looks the same, to give us the same results. So for example, let's say we are given the sum of negative 1 to the I over 3i plus 1, where I goes from 2 to 5. We would like to rewrite the series, so that instead of index I, I'm going to change I. It has index j, whose or let's say where j starts at 1. Where j starts at 1. So how do we handle this? Well, we would like to start this with 1, not 2, and change the index from I to j. So let's start with the given series. Negative 1 over 3i plus 1 to the ith power. So what we're going to do is we are going to rewrite this. Sorry, this was 2. I want to make that 2, 1. To make that 2, 1, I'm going to subtract 1 on both sides of this equation, I equals 1. So it becomes I minus 1 is 1. And since we did that here, this was from I equals 1 to I equals 5. So that becomes I minus 1 equals 4. So I subtract 1 on both sides of that equation as well. Let's keep this the same for now, over 3i plus 1. So what I just did is called shifting to the left. So now this negative 1 stays the same. Let's see what's going to happen here. This part, the I minus 1, I'm going to make it j. So the I minus 1, I'm going to replace that with j. So what I did, I minus 1, replace it with j. So on the top I get j equals 4. And so what does that mean? Remember, if I change the indices to j, then I can't put I in there anymore on the right side. So what I need to do, I need to know what I is. I is going to be j plus 1 if you add 1 to both sides. So here you do j plus 1 plus 1. And on the top is j plus 1. So let's keep this as is, j equals 1 to 4. On the top nothing can be done, but the denominator we can multiply, distribute 3j. 3 times 1 is 3 and 1. So that simplifies to negative 1 to the j plus 1 and 3j plus 4, where j goes from 1 to 4. That's how we change the index to start at 1. Let's look at another example. Let's do the same. For the sigma 5i plus 3, where I starts, let's say 4 to 11. 4 to 11. So how do we start with this one? Again, I want to make it start at 1. So to make it start at 1, I need to subtract 3 on both sides. And same thing here, subtract 3 on both sides. So I minus 3 is 8. So the main thing is to make this number 1. Let's keep this the same for now. The next step, this is going to be j. So let this equal to j. So this means I is going to be j plus 3. I is j plus 3. So let's see what that gives us. This goes j equals 1 to j equals 8. 5 times j plus 3. I replace I with j plus 3. And there's another 3 out there. So let's keep this the same. J equals 1 to 8. This is 5j plus 15 plus 3 is 18. So that's what we got here. So that's how we do the index, change it to start at 1. What about another example? Sum j starts at 2 to 9, or I equals 1 to 9, of negative 1 to I minus 1 times I cubed. So we want this to start at 1. So what you do for this, I minus 1 equals 1. I minus 1 equals 8. So I subtracted 1 from each equation on both sides. Keep this for now the same. Then replace or substitute this equal j. So I equals j plus 1. So what do we get? I minus 1 is j equals 1. J equals 8. Here negative 1 to I minus 1 is j times I is j plus 1 cubed. So everything was changed from I to j, where the index starts at 1. That's all we need. So we looked at what a series is, how to find the kind of like using guess and check to write a series as a sigma notation. And then we learned here how to change the index, Another good thing to learn is the sum of an arithmetic sequence, Is there a shortcut to find sum? Yes, there is. So an, we define an to be the nth term of the sequence, nth term of the arithmetic sequence. A1 is the first term of the sequence. And n is the number of terms. So from the previous section, recall, we proved an equals a1 plus n minus 1 times d. And here what we're going to learn is the sum, which I'm not going to prove now, is the number of terms divided by 2 times a1 plus a2, the sum of this. That gives us the sum of the arithmetic sequences. So, let's look at an example. Determine the sum of the sequence 2 plus 4 plus 6 plus all the way to 88. Well, that's going to take a lot of time. If you want to list first all of them and then add all of this stuff up, that's going to take a lot of time. So we have noticed every time they're adding 2 to this, so that's an arithmetic sequence. A1 is this is A1. This is AN. The only thing left to find is N. What is N? Well, the only thing I know about arithmetic sequences is this formula and this sum. But I can't finish with the sum. I need N. So I'm going to try to use the first formula, the AN formula. So AN is A1, hoping that's going to help us with finding or to solve for n. an is the last term, 88. a1 is 2. We're looking for n. What is d? What they're adding every time? Well, they're adding 2 every time. Let's see, if you subtract 2 on both sides, you get 86 equals 2 times n minus 1. Divide both sides by 2, you get 43 equals n minus 1. So n is 44. This is what n is. So now I found n, then I can find the sum. Is n over 2 times a1 plus an. So what is n? n is 44 over 2. a1 is the first term, which is 2, and the last term was 88. So now all we have to do, the sum is 22 times 90. So that gives us, if we multiply it out, 1980. So that's the sum. Let's look at another example. Find the sum, or the value of the sum. Negative 6 plus 1 plus 8 plus 15 all the way to 50. So kind of similar to the previous one. First we need to find what n is, so we use the formula an equals a1 plus n minus 1 times d. This is an arithmetic sequence. an is 50. a1 is negative 6. I don't know what n is. d, every time they're adding 7. So now add 6 to both sides. You get 56 equals 7 times n minus 1. We can divide both sides by 7. We get 8 equals n minus 1. n gives me 9. Means in total there's 9 terms. But remember, I need to find the sum. What's the sum of this? Well, the sum, by the formula n over 2, a1 plus an. n is 9 over 2. a1 was negative 6. And an was, the last term was 50. So that gives us, keep 9 over 2 the same. This is 44. We can simplify here, reduce by 2, 1 by 2, 22. So 9 times 22 is 198. That's the sum. One other example, find the sum, but I'm going to have it in a different way. Sigma 2i minus 8, I ranges from 1 to 24. So we need to find the value of this sum, like an exact number. Not just write it down. But for the meantime, the first thing we should do is basically write down the series. Well, what is that going to be? If you substitute I equals 1, you get 2 times 1 minus 8. Substitute 2, 2 times 2 minus 8. Substitute 3, 2 times 3 minus 8. Plus all the way to 22 times 24 minus 8. So what does that give us? 2 minus 8, negative 6. 4 minus 8, negative 4. So let's write minus 4. 6 minus 8, minus 2. Minus something something. 2 times 24, that's 48. That's going to lead up to get 40. Just 40. Then, how to find the sum here? Well, we need to know the number of terms. We have a1 and an. So we have to use the formula. an equals a1 plus n minus 1 times d. an is 40. a1 negative 6. I don't know what n is. And d is, every time they are subtracting 4 or adding 2. Yes, adding 2. So then, add 6 to both sides. We got 46 equals 2 times n minus 1. Divide both sides by 2. That gives us 23 equals n minus 1. Add 1 to both sides. You get n equals 24. That's n. And now we can find the sum. The sum is n over 2 always. The first term is negative 6 and the last term is 40. So that gives us 12 times 34. And if you multiply that out, what do you get? 408. 408. So that gives us the sum of this series. Now one note, I want to make a note about n. You know how we found n here, right? This is n. Another way to see this, or another way to see it, look at the terms. The terms are ranging from I equals 1 to 24. There's 24 terms. Always, if you want to know what that terms is, the number, it doesn't mean, it is not only if there's a 24 means 24 terms. It's always the higher term minus the lower term plus 1, always. So always the higher term minus the lower term plus 1, which in turn gives us 24. That's a shortcut to find it if it's given in a sigma notation. So if they ask us to find the number of terms, find the number of terms, not the sum, just the number of terms. In the sum, let's say anything here, 2i plus 1. I goes from 3 to 72, let's say. So the number of terms n is going to be always the highest minus the lowest plus 1. So that would be this is 69 plus 1. So there's exactly 70 terms.